The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
Well, it's 10 o'clock. Should we kick off? All right. We're going to start just to be respectful of everybody's time. So thank you for coming to, well, largely Noah's talk. As usual, I just play Vanna White here. So I'm going to do the introduction and then it'll be the Noah show. No, I'm kidding. We're going to talk about some of the considerations that we have. Sure, you can close the door if you want. Some of the considerations that you might think about when you're thinking about moving out of the cloud, whether you're going to your home lab or doing this kind of professionally like Noah did. So when we were considering how we should structure this, we thought, how do we frame this? And ultimately, you don't make a decision like this lightly, right? Because if you start off with a managed service and then you need to take that on yourself, there's a lot of additional challenges that come with that. You have to be the one in control of everything. And there's a reason why you might do this, right? So with the world moving to the cloud, people expect the services to be out there somewhere and just be ephemeral, right? It's all kind of nebulous to them. Ultimately, what we want to achieve is be able to be in control of your own destiny. And that is ultimately where if you're running things that people depend on, whether it's your family or your business, there's nothing worse than saying, I'm sorry, I can't help you. It's literally out of my control, right? Because if it's your business, people are saying, well, what am I paying you for then? So there is definitely some challenges there. And ultimately, the decision is whose computer do you want to end up using? So when the cloud is down, what do you do? For me, it's all about running things locally so that I'm resilient against the cloud. So I actually found out that there is all of this internet-wide problem when Noah's like, hey, did you hear there's a problem in the internet? Like, I had no idea, right?
Show of hands, who was affected and or whose phone blew up on whatever was Thursday? The cloud. Okay.
There's few people that were, yeah. It was pretty widespread. Like, I didn't even bother opening my work emails after I heard about that because that totally would have affected us. And I told them, don't call me because I'm giving talks. But my wife is normally the barometer of like, hey, something funny is going on. And I start getting messages. And the fact that she didn't give me any messages told me that we were resilient to this problem, because she doesn't do it to like, hey, you need to come and fix this. But after years of marriage, it's been like, if you don't tell me, I can't fix it for you, right? So just tell me when it happens, so at least I'm aware of when you have recognized there's a problem. So locally hosted stuff is a big deal for me. I use a lot of stuff professionally that I self-host, right? So even though I work for Red Hat, I self-host my own Kanban board. I have many, many tools that I use. I have 29 services at home that are just web-based alone that I use to do my job. And it was one of those things that when you don't have access to Google Cloud because the client blocks it, or you have, there's some restriction, or the company just decides, you know what, you can no longer use Trello. That's a problem, right? So we had a tool called Lucidcharts, and there's a corporate decision to move away from it. Lucidcharts is like a graphing tool that architects use all the time. They took that away from us and then didn't give us anything in return. They were kind of like, here's Miro, but Miro is like digital sticky notes. It's not an architecture tool, right? So most of us went, well, nuts to that. I'm going to fire up my own Draw.io service, right? So all of these things make you resilient to all kinds of problems like connectivity and stuff like that.
Has anybody, show of hands, who has been reliant on a cloud service and couldn't get to it? Okay. Kind of exemplifies the problem. So we were trying to think about some of the most egregious examples we could give to scare the loving bejeebers out of you if you're sitting in this room and nobody didn't raise their hand. And the best one that I could think to come up with, you've all used the little hotel door locks, right? Take the little key, put it in. There's there's a handful of companies that make those in large scale and do them for large hotels. The 800-pound gorilla in the industry is a company called Onity. And for obvious reasons, the encoder that encodes those key cards, you can't just call Onity and say, yo, I'm at a Super 8 and I ordered the encoder off of eBay and I want you to program it so I can make cards for this Super 8. They're not going to do that for you, right? And so the only way to get an encoder provisioned with the key necessary so that it can make the little key cards is from Onity themselves. There is the new versions with the little tap to touch are all over the place, and most of those are PC based, but there's an older version that relied on an RS-232 connection that Onity would send this encoder programming down and they would provision this encoder. So it was not unheard of. We work in the MSP industry, and so we deal with Wi-Fi hotels, and that basically means that anything that has a plug on it, we call those guys and they'll come and try and fix it, to include this key encoder, which we have no professional training with, no relationship with Onity whatsoever, and yet it's a thing that wound up on our doorstep over and over and over again. Hey, the keys don't work. Why? Well, the reason is those encoders have two batteries in them. There's a primary power source and then there's a backup battery. And then the idea is that you only disconnect one of the power sources at a time. You're changing the main batteries, you're changing the backup batteries, or you have an AC outage, that sort of thing. We did a little too good of a job in the IT industry of convincing people that when something doesn't work, the answer is to get it completely to turn off and then turn it back on. And that occasionally leads to those encoders losing their programming and you have to redo it. And it's a big, long process. You have to find an actual copper phone line, which are really hard to come by these days. You have to have a specific kind of modem that can talk to it. So we have this big contraption that sits inside of a little case, and it's a crash kit, so we can take it out and say, we can reprogram your encoder. We got to a hotel at, I don't know, 11:30 midnight because they said, hey, it's not working. Well, it turns out Onity is discontinuing that old cruft because it's been around forever and they want to get rid of it. And they've now told the guys that the only human beings on planet Earth that can program these door key encoders, you can just take off at like 8 o'clock at night and you're good. We'll see you at 7 in the morning. So there is no human being on planet Earth that can answer the call to reprogram one of these things. We're standing in a hotel, a lobby full of people, all like you, going, my suitcase is in my room and I can't get to it. I swiped the key and it's red. No answer. And it is the most helpless, debilitating feeling I can possibly describe for you when you're looking at somebody that's saying, please help me, please do this thing. I'm a techie. I have all the things. I found the 56K modem because I knew it. I had the little parallel card to convert it. I found the only copper line on planet Earth that doesn't use an ATA because I do know the difference. And it doesn't matter. There's nobody at the other end of the pipe that's willing to answer the call and to fix it. And so because of that, we had to look the guy in the face and say, I'm sorry, this lobby full of people, they're all going to be having a sleepover here because we can't get them into the room. And so your choices are you can take that DeWalt drill and start drilling locks, or you can roll out some sleeping mats and have a nap. The cloud isn't perfect. So show of hands demonstrates these screenshots are just from 2025. This is just from this year. This is going to be an increasing problem in our society. As good as we are at our jobs, as good as we are at nerds at making things resilient and highly available, and we come up with we've reinvented the wheel 100 different times to find ways to make sure the thing stays up because we know it costs money. We know we don't want downtime. We know all that. And in the end, nothing is ever going to be perfect, and so it's always going to go down. And so I can talk to you about a key encoder, and you're looking and saying, never heard of that, or that's never happened to me. But everybody in this room, as evidenced by the hands that went up, has experienced this. And so to a degree, we have a certain level of responsibility as technologists to come here to a conference, learn how this stuff actually works, and continue to practice the ancient art of it's the computer. And if you set it up from scratch, it will do things for you. And it's right there in the palm of your hand instead of this, as you put it, the nebulous, it came down from the cloud and somehow it showed up and I signed in and my account was there and it worked.
So there are a lot of things that you can consider when you're moving out of the cloud. You could do a transitional step of moving to like a VPS, like a virtual private server, right? So it's kind of like an intermediate step between a cloud hosted thing. It is still in the cloud because it's not your computer, but it's something a little more directly under your control. It still has the same pitfalls as a cloud operated thing, right? So if you go to DigitalOcean or Linode or wherever it's like that, there's a low barrier to entry. Oftentimes there's like a one-click deploy of the thing you want to do, and that's wonderful for deving, and it probably goes to production because that's how we roll. You can scale it to some extent, right? Depending on the application that you're running, you can scale it out, or you can go to EKS and run their Kubernetes and have it scale out and do all the things. It's flexible, it's wonderful, it connects with all the things, except that you're usually pretty much stuck there. If you're running Kubernetes, there's some flexibility because you export your configs and bring them in somewhere else, and hopefully they'll work. But ultimately, that's probably not where you want to be either, because you're still going to suffer from, it's kind of the worst of both worlds in some ways, because you're still helpless. If it doesn't work, you pick up the phone and you go in a queue, and everybody here in the room, to include Red Hat, gets in the queue and has to wait, right? Unless we've got a giant lever because our client is really huge. We just sit in the queue like everybody else. And so good luck getting a timely response if there's an internet outage or something like that and you're trying to recover from it. It does give you a quick on-ramp, but like I said, there are still some really big downsides. It's an interesting middle ground you could choose to explore. One of the kind of answers to help with this is this idea of Kubernetes, right? So in the old days, we had this monolithic architecture where we'd shove everything on a machine, and then maybe we've got a bunch of machines working together, like doing the big iron thing. And Kubernetes works to kind of help alleviate some of that stuff. So you could, in theory, stretch your Kubernetes cluster from your data center to the cloud if you got lots of money and you can afford the uplink and storage isn't a consideration, and. There are ways around this that will help if you're a big place. And it's also a viable option for anyone in this room if you are willing to understand how Kubernetes works, because like I said, what is nice about Kubernetes is it's basically declarative. So you set out your configuration file, you feed it in, theoretically it kicks out an app, then you export that, and then you bring it to your home and you run it there, and theoretically it kicks out that app. There's lots of caveats, like if it's an AWS, it uses their load balancer. If it's an Azure, it uses their load balancer. You bring it home and you're like, why don't I have connectivity? Right, I don't have those load balancers, right? Like, so there's some pitfalls there. Kubernetes can help bridge some of that gap. It's probably overkill for most of the people who are in the small business world. It can be okay, right? I don't want to scare you away, but when you're thinking about things like redundancy, probably 2 servers is where you're at for a large portion of the type of customers you're going to service. If you're at home, run it because it's cool, but don't run it because it takes a lot of resources that you probably don't need. I don't. I have a lab professionally for my work. It does not host my home lab. It's a bunch of giant metal servers that I turn off at the end of the day because I suck a lot of power. That runs my Kubernetes stuff. My actual, like, this stuff needs to be up all the time, does not run Kubernetes because that would require me to scale my lab out too far.
So the origin of this project actually started right here itself. Pandemic hits, can't meet in person, what are we going to do? And so the nerds of the internet got together and said, open source thing exists that we could get everybody in, we could do a virtual conference. And that year, we landed on Matrix. Up until that point, I'd never used it before. And so, but in about 24 hours, we had a Matrix server set up, we had rooms created, we had individual things for speakers, we had the ability to bring audio and video in, and we were doing all the things. And afterwards, it kind of stuck around, and people were hanging out and people were chatting. And at the time, we were using a different chat communication thing that was cloud-based for our work. And some of the guys that worked at my IT company had attended Self and were in that Matrix instance, and they said, why don't we just use this? this would be great. And so we did the only business responsible thing. We took something that wasn't even in a 1.0 yet, and we decided, sure, let's run a business on it. Why not? And so we switched over to it. It has been rough. There are absolutely rough edges. Talk to anybody that's used it. There are rough edges. However, the second something else comes along that allows me to stay in communication with people, that doesn't get shut down, kicks people out, switches protocols, all the things are great. The reason that landed itself was, if I'm being honest, because we could bridge it to IRC. And so all of the people that were graybeards and loved IRC, and that's where they existed, it was a one-to-one for them, and it was built by people that used IRC, and it worked really well. And so then they added, the modern messaging stuff. So we had this community instance, we'd set it up, we didn't want to kill it. But after it had been around for a few years, we left public registration open because, you want to, be inclusive, or we want to let people come in. So we left the registration open. And it turns out if you leave a server on the internet and it's open to anybody, they all sign up. And then they store their stuff there. And then they live there. And then the server grows along with the bill. And so we got to a point where we were running the thing on DigitalOcean, and it was just becoming, we're watching the dollars tick up. And of course, I'm going back to, the people, we're sitting down to have business meetings. We're like, hey, the DigitalOcean bill is creeping up, and who is Linux Delta, and how much are they paying us? And I'm like, oh, right, that's for the Southeast Linuxfest and the hobby server that we ran. They're like, yeah, we probably need to separate this from the business, right? And so we started looking at, what would we do? How would we run that? Because we could just shut it down, right? We could just say, hey, it got us through self. We're back in person. And it was never designed to be one gigantic server. It's designed to have a bunch of little instances. So go on, set up Synapse, and it'll be good. And as we started to talk about it a little bit more, we said, okay, so if this is getting out of control, sure, today it isn't tied to a paying client. But what is our plan when a client comes to ask us to host a thing that occupies a ton of space, that requires a ton of compute, that needs more memory? What are we going to do? And we saw even then a world in which we're building all of these very customized VMs for clients. If you want the easiest way to manage Windows, virtualize it and then let people get into Windows. And what that allows you to do is snapshots, and all the things that are bad about Windows go away. Not all of them, but a lot of them go away because you can roll back and you can augment Windows' goofiness. If we were to do that, it would quickly run away just like the Matrix server did. And the nice thing about the Matrix server is it was all built atop open source technology. So there's places you could go and ask, how do you scale this? How do you do this? How does this work? So we looked and said, okay, if we were going to go rent space in a data center and we were going to go put a server in here, this would be a pretty decent one to start with. It has a pretty complex stack. It's resource heavy enough. We've got, thanks to everybody that signed up for a free account, free QA testing, and let's see what happens. So we bought a server, we put some drives in it, we put a drive in it, we drove it down to the data center, we stuck it in the rack, we plugged the Ethernet cable in the back, we gave it an IP, and it turned on. We're like, yes, we've done it. And so we migrated over the process of 4 days all of the data that was in DigitalOcean onto the data center. And then we clicked the button. And we waited. And we waited. And 24 hours later, you could finally connect to it. Kind of. And it worked. Sort of. If you sent a message, it eventually posted. And eventually got read. And so we started thinking about it. We're like, man, this isn't enterprise quality at all. This is terrible. This is an abysmal experience. Nobody would want. Hey, friend who does enterprise technology, we took the server, we eBayed and stuck a drive in it and plugged it in. It's not working. Why is that? And Steve goes, well, what's your user load? I have no idea. How often is it hitting the disk? Oh, I have no idea. I stuck the disk in there. It's definitely there. It runs. How much memory is being used? All of it. How much CPU is in use? Well, it depends on what's in use. I mean, I don't sit down and take a pad. And so there started the venture of collecting information about the server, getting enough observability into what we were using so we knew what the heck we were using, so we knew what it is we were trying to build, right? And I think, yeah.
So Noah comes to me, and I just start doing the architect thing. And largely, an architect doesn't. Sure, we do a bunch of development type work, and we sit down and think about how all the components connect. But really, what you are is a detective. You go and ask a bunch of questions, right? And see what the person knows, and see if they've thought about things. Because sometimes just asking questions like actually prompts them to realize they didn't know anything about it, right? They don't know how it's running. They don't know how it connects to things. They don't know. They don't know. They just don't know. Sometimes they don't even know the login, right? So you start asking questions, and when it was apparent that there was some gaps in knowledge, I started laying down some suggestions like, well, what specifically are you running, right? Okay, I don't know what Matrix is. Like, I know what Matrix is, but I didn't install it. It is not my project. I don't know what parts go into it. What specifically is running? Telling me Matrix is running doesn't help me like level the playing field. Like, okay, it's a giant ass database. That helps because here's your profile, right? So you start thinking about like, what is my performance profile? You start thinking about things like, is this thing composable, right? Does it have a bunch of parts, and can I move this piece over here and still leave the rest in place? Or do I have dependencies that have to move together? Can I migrate in chunks, right? So if you have to grab the thing and move it all at once, is there some facility to move in Delta? So like if you're transferring a VM, lots of hypervisors have what's called change block tracking. What that does when you turn it on is it basically figures out from the point that I turn it on to some point in the future, specifically which blocks have changed. And the reason that you do this is because you can do a block level transfer, which is quicker. Instead of picking up, so I have a client, we have a VM, we have VMs that are in the terabytes in size as a regular. So we are 10 months into this migration project, and the average VM size is 650 gigs. That's the average VM size. So you can't just pick this up during the day and then move it over there, right? And so the change block tracking, the VM has to be up. The business can't go down, right? So stuff is happening on the VM. So you can't just literally copy it in the background and turn it on the other side. So change block tracking basically allows it to continue to run. And when you turn it on, it says, okay, from this point forward, start tracking all of the writes so that you can copy this write over here. And you're actually making a one-to-one block copy. And what this allows you to do is over the course of, honestly, 5 or 6 days when they're this big, you finally eventually get all this stuff over there, and then it will look at what kind of RAM is being used, copy the information out of memory, and put it on this. And so then you have literally exact copies within a couple of seconds, right? There is going to be some disruption when you do this because it is really, really hard to have 2 active machines being perfectly identical when you're only sending traffic at 1 machine. But these are sort of the things that you start talking about. So Matrix didn't have a ton of that, but there was some facility that Matrix was able to accommodate there. But as part of this, one of the things you need to think about is like, what am I trying to do here? Do I have a baseline? Do I understand what my application is doing? Do I understand okay, so DigitalOcean has CPUs, and largely the cloud vendors will obscure this from you unless you go dig for it. Like, you can specifically say, I want a 13th gen Intel Xeon. You can do that. But if you just say, give me 2 cores, you don't necessarily know what you're getting, right? So knowing that you have 4 cores, and then Noah goes to eBay and buys a 10-year-old machine, and it's got 16 cores, well, that should be better, right? Well, not necessarily. And so part of the way that you track that down is to kind of figure out, like, what does my profile look like? How's the CPU look like? Where are my traffic bottlenecks so that I can actually do my transfers properly? And it turns out we weren't really collecting anything. We didn't really know anything about that.
Who here has been moving something with a buddy and you get to the very end and that's not going anywhere. Right. So we did that seems to run. Like, spun it up, turn it on, that runs.
Well, but in fairness, though, you're not alone. Like my job exists because giant companies do this, right? You walk in and you're like, you're a Fortune 10 company. You don't know how this runs. Okay. right? Like, so it's not a Noah thing. This is human nature. It's like we turned it on. This is normally the way it goes. Hey Joe, I got a problem. Yeah, install that software over there, and like we'll test it out. Cool. And then 15 people start using it, and everybody tells their friend, and now everybody's using it, and it just rolls out. That's how it works, right? And so because of that, there isn't performance profiles and stuff like that. So you're not alone.
Everybody's fortunate enough to have a development environment. Some people are fortunate enough to have that separate from their production environment even. It's really fancy. So we started to collect metrics, we started to learn to what we need, and then we started to build out like, okay, if we were going to do this from scratch, what would it look like and how would we set that up? And so what we landed on was 2 identical servers, 2U servers. We mirrored the boot drives. Then we had a separate pool of drives that were being used for all of the data. And there were 3 drives per VDEV, and then there were 2 VDEVs per system. And so ZFS for the storage. And the idea was that we had a nice clunk of keys to write to and to be able to easily pull data on or off the server. And the original plan was the first one was going to be the primary server, and the second one was going to be the backup server. And the idea was primary server ever failed, and we'd just slide all the VMs over to the backup server, and that VM pool was syncing so that we just start the VMs up on the other guy. As we started to get into it, we figured out, well, actually, it kind of makes sense to run half of the VMs on one and half the VMs on the other because we got better performance. So we did that. And I never once, in any of the platforms that I had access to, I never once said, hey, we're doing this hosting thing and you should come up and sign up for services. Those words never left my mouth, ever. And yet, before we even completed the project, both of those servers were at capacity because new people came and said, we want to pay you money, we want you to host this thing. Now, we had a choice, right? We could have said, no, we don't want your money, but that's dumb. The second thing we could have done is we could have said, we'll take your money and we'll put you on the cloud while we're building this thing over here because we think this is the way to do it. And we'll put you over there. That didn't really sit well with us either. And so we said, okay, here's what we're going to do. As these people come to us and say, hey, we want you to take this on, if we're going to do it, we're going to onboard these people on here and we're going to just fight through the pitfalls. As we run it, as we stub our toe, we knew we were going to do it. We were honest with people. We know we're going to do it. We're getting into this space. We're going to stub our toe, but we're going to do it. And so we let those machines fill up. And once they started to get to the point where we started to look over and saying, okay, if we ever have a bad day on either one of those machines, it's going to be a really bad day. We decided we needed a 2.0 version of this. And so 2.0 was born. The 2.0 went from an Intel very old server to a less old server that is running an Epic system. Again, the mirrored boot drives. The thing that we changed, again, you learn as you go along. When we built this the first time, we were really concerned about redundancy because the data center's 5 hours away. And so we were doing calculations of here's what it costs us to get somebody down there. Here's what it costs for a hotel. Here's what it costs for gas. Here's the time it will take. And so we really, 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 really didn't want anything to die that would take the server completely down before somebody could get there. It turns out in practice, it's a terrible idea because of parity. So in iteration 2, we did 2 drives per VDEV, and now we just copied those VDEVs as we need to scale, and that works much better.
So anybody that was at my hiring talk yesterday, and I said, ask questions, right? Was not consulted about how the drive should lay out, which is fine, right? Noah's company. But I would have been able to tell him you did mirrored parity bits and that was your idea of performance, right? Like some of these things, asking the question, there's a balance between trying to get a bunch of things for free. Noah and I are friends. There was no money exchange. I would have drove up and worked with you, right? But then you're also sensitive of like being imposing on people. However, if you've got expertise there, throw the question out and just say like, hey man, this is what like I think, can you just do a flyby over it? Like lean on your friends because you would do it for me in a heartbeat, right? Like if I said, I need you to look over like the amount of Wi-Fi problems that I've had, right? Like
when that works, let's go back and talk about parity bits.
Right, but I'm just saying like we ask each other these things, right? So lean on the experience when you can, right? And your friends will help you out.
100%. The other thing is you don't know what you don't know, because I probably learned more in just side conversations with you going, hey, yeah, and I tried this and that, and well, hey, have you thought of this, or have you looked at this, or sometimes just sharing a war story of, hey, this really worked well, and you steal that idea and go, man, that would really work. So second time around, much better. In fact, it was interesting. So we put the thing on and we get all the VMs moved over and we fire everything up and we look. That single server is now handling at 50% capacity, I might add, all the load that was spread across the other two. So we were in a way better boat. We've got 64 cores on, or that server will handle up to 64 cores between two processors. They make a 1U version that will do half that amount. And so that's it. Iteration 3, or I guess iteration 4 now, we're going to look at that a little bit to decide how much value is there in having all the things on a box, or a box that can do all the things, and how much value is there in splitting that out. And so you've got some modularity so you can take them out. Because one of the things that's been really nice, as we add new servers, it's really wonderful to be able to go down to the data center, put the new one in, get the thing slid over, and then the next time you're there, pull the old guy out. That can come back to the shop. You can work on it on spare time, test things, get everything ready, and then you just kind of have a rotation going. That's worked out really well. The other note about the mirrored boot drives that was really cool, and I don't take credit for this, is a guy by the name of Dark Decoy figured this out. He wrote a little Ansible recovery script, because when you have a mirrored boot drive using MDRAID, the UEFI entry doesn't know which device to look for. And so if the drive fails, the data's there. Somebody just has to walk up to the machine and say, don't boot off of that one, boot off of that one. Well, there's nobody there in the data center to do that, and we wanted it to come back on its own. And so he wrote a little recovery script that basically, if it can't boot, it fails, it kicks off this little Ansible thing, it goes through and says, change the UEFI entry from this guy to that guy, and then boots back up. Yeah, it's pretty cool. So, I think there was, I thought we had a slide for 3.0.
See, this is why you don't script yourself, right?
Yes. There's one last iteration I want to get to. So Steve, in his infinite generosity, I was at his house and he looks and he says, I have this old server laying around. I'm not using it. Do you want it? And I'm like, free hardware. Yes, absolutely. I took it and I played with it and did some lab projects on it at home, but I didn't really have a particular use for it. And as we started to look at, so at this point, we were trying to get everything off of any cloud thing that we had had. And we'd had it spread over a couple of places. DigitalOcean for all of the just things. And then we were using Vultr, because Vultr lets you upload a custom ISO, which is really, really helpful in a world where sometimes you have appliances that need to be able to run, and you can upload the custom ISO and install it. And so we were starting to pull some of that stuff down, and we started to think about it. We were intentionally limiting ourselves, right? So anything that was running that was our service, that was for our company, that wasn't a paying client, that always went to the end of the back of the caboose, so to speak. And the problem with that is you're trying to dog food your own stuff, but you have a miserable experience, and you know you have a miserable experience by design, and it's not great. So the way that we chose to augment that was we took Steve's Genera server and set that up to use, so it's set up in the exact same way that this guy is, but it only hosts our internal stuff. And so now we're running on separate hardware, but we're running the same way that our clients are, and we have a much better experience.
So there's a lot of considerations when you're trying to extract yourself from the cloud, right? There are so many pitfalls, and a big part of my job is to help uncover those pitfalls. And so when we walk through this process, some of the things that we thought were worth sharing is thinking about, like, you're switching your tech stack, most likely, right? So you're still running Matrix, but you have to do something with the underlying infrastructure. So before it's abstracted away, largely you don't know what the infrastructure is running, only what's on your VM. So you are switching your tech stack in some capacity. Even if you are super familiar with libvirt or proxmox or whatever that is, the opportunity to actually move this over and consider something new is there. And so you might even switch the thing that you are comfortable with in order to accommodate the nerd, right? That's ultimately what it is. But this butts up against this idea of timelines, right? So you don't have an infinite amount of time to get off things. As a person that is trying to control your own destiny, you can bump that timeline out if you choose to. But if you're trying to do this in any sort of meaningful way, you'll set some sort of cutoff date so that you're not half here and half there. And the challenge with this is scope creep is a thing for everybody. And you've got this greenfield opportunity. So greenfield is like, hey, I'm doing a brand new project from the ground up. I can reconsider everything. I can look at Proxmox, and then I can look this up with Victoria Metrics, and I'm going to plug it in with this thing over here. And I also wanted to see, like, what's the difference between Chef and Ansible? And I can do all of these sorts of things. That's probably a really bad idea. On one hand, it's the best time to do it. On the other hand, it's the absolute worst time to do it because you need to make it work. And when you're pulling it, when you're doing such a large shift, is it like, which little thing that I turned is causing me this pain? I don't know. Like, do I have some sort of weird thing in my Ansible script that I didn't think about? Is it like Proxmox handles ZFS just slightly differently than the way that like the native ZFS works? Like all of these things you don't know, and you will bump into them. And so I deal with large migrations all the time. And although it's unpopular, I tell them all the time, one thing, do one thing, please, just one. Right? I know you want to change all the things and it's exciting to modernize your stack. Just one, please. Because there are blind spots and you don't know what you don't know. And there's a lot of that. There is a ton of that, right? Even an experienced person hunting up blind spots, there's always something that I don't know because I don't know the way your esoteric app works. I didn't realize that there's like this one dependency here. So a little bit of a war story. We spent hours searching up this problem because we were doing a migration of this app and the owner's just like, it doesn't work. Okay, well, that's not a super useful thing. They're like, well, it seems to be a firewall blocking thing because there's no, like we send the request and nothing comes back. We're spending a lot of time. And finally, so I'm letting the client kind of hash this out because it's their app and I don't really know much about it. And I was like, what exactly are you sending? They're like, oh, well, we make this request. I'm like, right, but what is that request? They're like, it's a UDP request. Okay, so it goes out and you never expect a response. Like, how am I supposed to track that, right? And it turned out that what they were doing to validate their app was they'd send a UDP request to a switch somewhere way over on the other side of the world, and it would just dump its config. And if they could do that, they're like, cool, we're good, right? That's your test, right? Like that was a blind spot in the migration that nobody had any idea that that was the way that we were QAing the app. So you get a report of like, it doesn't work. What doesn't work, right? So this leads to the idea of like connectivity. So there be dragons in connectivity. There's so much to think about here, right? So there's data connectivity, which is where the nerds go, but there's also like, how do I get at the failed server if it's failed? What do I do? Like, can I call remote hands? You know, how do I deal with getting my supply chain? If a hard drive fails, can I ship it to the data center and they plug it in? Do I have to go drive? Like, there's all kinds of things, right? So they control the network. There's nobody else to call, right? So if you've got a network problem, you have to be the expert in tracking down where is the problem. Is it latency? Is it throughput? Is it a hop somewhere out on the internet you don't have any control over? So there are learning curves. I know I just said there are timelines, but you need to slow down and really work on the learning curve, because when you're adopting all of this new stuff, you're learning how to do a migration, you're learning how to be a data center, you're learning how to like self-host. Even if you've got a lot of experience with it, you might not have self-hosted that thing, and there is a learning curve just to that aspect alone.
So as we went through and tried to figure out what we were going to do, what stack we were going to land on, we started by just sitting around in a room and just going, show of hands, who is using this? And it ended up being Ubuntu, 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 Alma. And I went, okay, all right, so we're going with Ubuntu then. And it turns out there were some advantages from the standpoint that ZFS was built in. And so some of the, it was an easy on-ramp. The nice thing is when you're using open source technology, you can swap components out without having to relearn everything. And so what we were comfortable with on our laptops and in our homes was what we wanted to put at the data center, because then it just became an extension. And that turned out to be a really great design decision, because since that time, we do, I wouldn't say everything, but a significant portion of build it on a laptop, build it right here, get everything dialed in exactly the way you want it, and then just slide it over and give it a public IP instead of a private IP. And now that thing becomes live and it's on the internet. And so that ability to take even, I mean, we've never done this in the data center, but I've absolutely done this at clients, taking a really beefy laptop and going, that's the vhost for right now while I fix this thing. And all your VMs are going to run off of this really beefy laptop, and it's plugged into their Ethernet port. And there we go. Now we've got, a backup host to work on. So we've got some bandwidth to slide things around. libvirt. I don't have enough good things to say about libvirt. I started using libvirt back in the RHEL 6 days when I was doing my certification. Back then, they had switched over to, you're going to have, when you're doing your certification, they'll have a server VM and they'll have a client VM. And I was pleasantly surprised to learn when I left that course and I went back to my laptop and went, gee, that libvirt thing, oh, look at that. I can just install it and it works right there. And now I can virtualize. Wonderful. And I've never left. And so I started there, had been running it at my home, had played around a little bit with OVH. And so when we got to the data center, it went, okay, this is a really simple, tried and true way that we understand how it works. We know how to get it there, and we can use it on anything. And so added Grafana and Prometheus so we could get insight into what we were looking at and how the thing was actually working. And then PyKVM. PyKVM I have a love-hate relationship with. It's a great product. It's awesome. It works well. However, there's all manner of hackery you have to do to get it to work. And especially if you're building your own machine, this is probably less of an issue. But when you're trying to get it to work with enterprise hardware and they didn't have the right pins and the right things and the way it was set up, so you're running things out the side of the chassis and you have to power things over USB, and so you got little kids, and it's not an elegant or clean solution. But there is some value, and ultimately we decided there was more value in one consistent interface to, here's how, when he was talking about how do you get to the thing when it's down, right? You can get remote hands, you can get them to restart, you can do the thing, but what if you need to get a keyboard and a mouse plugged into the thing and you just need to be able to work on the server? How do you do that? And PyKVM was kind of the savior there, because it doesn't matter if it's an HP server or a Dell server or a Supermicro or whatever it is, different ways to attach the KVM, but in the end, it's the same interface to get to the thing and control the thing and do the thing. And so that ended up being really, really helpful. The other part of it is, if you're shopping for data centers, things I would ask: what do you charge for remote hands? Because it's everything from, well, if Fred goes in there and he'll help you if he's around. If Fred's not around and he can't help you, to we don't charge for simple things if we just need to pull a cable or restart it, to it's X amount of dollars per hour, and they'll bring a crash kit out and plug it in and you can be on the phone with them and say, what does it say? But I would have those conversations with the data center, find out what's available, find out what your costs are going to be if you're going to do that, and then compare and contrast that with, so if we have a bad day, how do we get somebody out there? Yes.
You're using Dell equipment.
Yes.
Why wouldn't you just use the iDrive?
Great question. When you're buying Dell new and you buy it with an iDRAC license, it's great. In fact, the later version, I think it's iDRAC 9, is so good that if it's most simple things, we're using that for over their HTML interface. The older version of iDRAC, I want to say there was some plugin that had to be inside of a web page, and because we were buying these servers secondhand, not all of them had the iDRAC license. And then a mixture of brands. So for those three, because the Supermicro is IPMI, the HP is ILO, the Dell was iDRAC. So there was a I don't know, a standardization desire, I guess. But that's why I say I have a love-hate relationship. Is the iDRAC a million times better than PyKVM? Yes, in every measurable way. It works inside of the web browser. The screen scraping is solid. You can do all of the UEFI features, and it's just better in every measurable way. And if you can afford to do that and are going that way, 100%.
A note about that. If you are interested in academic research, you might find that some manufacturers base their license key off of the MAC address of the BMC for academic reasons only.
If you look up on GitHub, yes, there are keys for all versions of HDI.
Okay, today we learned it. This is good. This is
Yeah, I was gonna say I used
Yeah.
HPE gear, and I got official license keys with plausible deniability because I bought it from a vendor that's well known on eBay, and it was like $8.
Yeah, you can get it cheap. Yep. But
so yeah, so those are the way you go. And really what this exemplifies is when you get inside of a room of other geeks and can sit around for a moment, you will learn so much. And the ability to learn and say, I can help you from stubbing your toe because I fixed that is why I think conferences like this are really, really important, and why I think the cloud will never replace the room of geeks that are in this room, right? We'll just be working behind desks running the cloud. So in the end, what we wound up with was two virtual hosts, two storage servers, primary and backup for the virtual hosts. The virtual hosts have gotten a little more squirrely just from the standpoint that, so we've got the ones that are on the customers, we've got the one that runs ours, and then we've got a couple of spares that we're using as we just to play the shell game. So you have enough space to move one out, to put the next one in, that sort of thing. And then the third resides right in our office. The third storage server sits in our office. So every one of those VM disks ultimately will wind up back in a box in our office. And so if push came to shove, I could copy that disk image, I could install libvirt in about 15 minutes, and whatever it is that's running 5 hours away in the data center could be running right inside of our shop if we had to do it.
that's it.
Oh, there we go. There was the
slide.
HP.
All right. So we're running low on time. We want to be respectful of people coming in behind us. There are a bunch of baby steps that will help you in this process, right? So thinking about automation, right? I'm not going to express as much as what we planned on doing, but automation will help you. Whatever you can do, automation can be a big help if you can iron that out ahead of time. Thinking about what is needed and when. So that is not a wonderful representation of an OpenShift logo, but OpenShift can be a really big help. That's not a sales pitch. I legitimately think it is it's a product that serves a really good need. And Mr. Cameron gave us a talk about how you can run the upstream version yesterday, so we can go find that if you're actually interested in that. ZFS is the core for both of us when we can use it. There's just so many good things to say about it. We had war stories about how it saved both of us, but we don't have time to that, so we're going to skip through that. Having people that are bridge builders is really important. Now, it's hard to find, but a bridge builder is a person that runs into a hole and then goes over, like builds the bridge over the hole. Now, I am not the smartest person. I report directly to a director, and there are 4 of us that report into him. I am by far the lowest on the list in terms of technical skill. But what I do, I'm his bridge builder. He will send me at a hole, and I'm going to pave over that. I'm going to gravel over the hole. And I say that because I'm the worst of the 4 of us. And what will happen is that kickstarts the process. I've tread the path and set the direction, and someone who's smarter than me comes along and is like, we need to fix this. And then they fix it. And so having a bridge builder is a useful process. And you kickstart that by throwing stuff against the wall, right? And that's ultimately what it is, because what kickstarts that process, people love to tear stuff down and poke holes in things. They don't like to be the one that puts the information out there first. So I think Noah does a really good job of fostering that type of community.
In the end, it was like what we got at the other end of this that we didn't have when we started was control over our own destiny. And so what I mean by that is, if any client pays us a monthly fee to host a thing for them, I will show up at your doorstep with everything needed to produce the thing you asked me to provide for you. And it hasn't happened often, maybe I was trying to think back as we were putting this presentation, maybe 3 or 4 times in 20 years, but there have absolutely been times. There was a time that we had a client, they got hit with a cryptoware thing. It took out all their infrastructure. It was, it's not physically damaged. We can fix it, and that we had backups of the data. The problem is backups of the data were in Grand Forks and they were 8 hours away. And so it's a function of how are we going to transfer that many terabytes over the internet? They need to be up and running tomorrow. And so Noah throws it in the trunk of his car, and 8 hours later, it was sitting in front of their office before business opened the next day, right? You can't do that if you're renting space from VPS A, B, or C, right? It's just not possible. And on Thursday, I, like probably many of you, am sitting with one client after the other going, why is my stuff not up? Why is this not working? This is broken. I can't get to this. I can't get to that. And I'm sitting going, you know what? We got the green check marks from Google, or we got red check marks from Google. We want them to get to green. In between red, they'll turn yellow, then they'll turn green. When they're red, we can't do it. It won't work. When it turns yellow, there's a sign of hope. When it's green, then we can fix your thing. Watch the green check mark. That's what we're looking for. I'll let you know when I see it. If you see it first, you let me know. It's not a great answer, right? But that's what you're left with when you don't have control over it. And so what it did is the same thing that we play with at home gets to be the thing we deliver to clients. The same thing that's in the data center means that in the end, I can take it, put it on a laptop, on a server, on a repurposed desktop, and hand it back to you.
So we were planning to go over like some of the stuff that is important to us, kind of blending this into the home lab. We don't have a lot of time for that, but we wanted to call out like projects that we use all the time. So for me, I have a couple of things that I use extensively for work. So I use Fast Whisper for local transcription. I always use this. Clients are okay with having transcriptions. They're not always okay with recording, right? Especially when you say, I'm just going to make like, it's local, it's not going anywhere. I'm just using it to make notes and I'll summarize for the thing. So I use this all the time. Same thing with Wiki.js. And then you get into the home lab stuff, like Jellyfin is out there. Audio Bookshelf is important for us, Mind Test and stuff like that for you guys. But we're out of time. So if you want to chat, we're going to be doing a live Ask Noah at some point today. And, you know who Noah is. And I'm just
Go out in the hall, find the microphones. We're all there. We'll answer your questions. We'll nerd out together. Thanks for your time.